NEC Section 400.12 addresses the use of flexible cords and cables. The proposal recommends adding a statement to Section 400.1 of the National Electrical Code. The addition states that this article, referring to Article 400, shall not apply to listed extension cords that comprise a complete unit with a cap and plug. The substantiation for this proposal rests on the common perception that it is illegal, according to Section 400.8, to run a factory-assembled extension cord through a doorway for temporary use. This perception influences the application of other articles, such as 210.63, which mandates receptacles within 25 feet for equipment servicing. Considering the infrequent nature of these tasks, it is deemed reasonable for a receptacle inside a structure to fulfill this need. A coordinating proposal addresses Section 210.63, stipulating that ground fault circuit interrupter protection is required for indoor receptacles also serving this purpose. This change clarifies that the National Electrical Code requirements terminate at the fixed premises wiring, irrespective of temporary conditions arising from the system's use. Current practices in many regions involve establishing a temporary service on-site, necessitating extension cords for constructing new structures. Under the existing code, it would be technically non-compliant for workers to plug into a temporary power source outside and run a cord inside the structure to work. The panel meeting action was to accept the proposal. Article 400 of the National Electrical Code pertains to flexible cords and flexible cables. Flexible cords and cables are designed for specific applications, and their use is subject to certain restrictions to ensure safety and prevent electrical hazards. Section 400.1 covers the scope of Article 400, defining the types of flexible cords and cables that fall under its regulations. These include cords used for pendants, wiring of fixtures, connection of portable appliances, and other similar applications. The general requirements for flexible cords and cables outline the standards for their construction, insulation, and ampacity. These requirements ensure that the cords are suitable for their intended use and can safely carry the electrical current without overheating or causing a fire hazard. Section 400.4 lists the approved uses for flexible cords and cables, specifying the applications where they are permitted to be used. These uses typically involve connecting portable equipment and appliances where flexibility is necessary. Section 400.5 details the unapproved uses for flexible cords and cables, outlining the situations where their use is prohibited. These prohibitions are in place to prevent misuse and potential hazards. Common and approved uses include using flexible cords as a substitute for fixed wiring, running them through walls or ceilings, or attaching them to building surfaces. Section 400.6 addresses the trade size of flexible cords and cables, specifying the dimensions and construction requirements for different types of cords. This ensures that the cords are properly sized for the intended application and can handle the electrical load. Section 400.7 covers the ampacity of flexible cords and cables, which refers to the maximum amount of current that a cord can safely carry. The ampacity is determined by the cord's gauge, insulation type, and ambient temperature. It is crucial to select a cord with an appropriate ampacity to prevent overheating and potential fire hazards. Section 400.8 lists the uses not permitted for flexible cords and cables. These include using them as a substitute for the fixed wiring of a building, running them through holes in walls, ceilings, or floors, or concealing them behind building structures. These restrictions are in place to prevent damage to the cords and potential electrical hazards. Section 400.9 covers the splices for flexible cords. Flexible cords should only be spliced if absolutely necessary and in accordance with specific requirements. Splices must be made using approved methods and materials to ensure a safe and reliable connection. Section 400.10 addresses the pull at joints and terminals of flexible cords and cables. These connections must be designed and installed to prevent strain on the cord and terminals. Strain relief mechanisms such as cord grips or knots are often used to secure the cord and prevent it from being pulled out of the connection. Section 400.11 covers the show windows and showcases. Flexible cords used in show windows and showcases must be of a specific type and construction to resist abrasion and wear. They should also be protected from physical damage and installed in a way that minimizes the risk of electrical hazards. Section 400.12, which this proposal modifies, addresses minimum size. Flexible cords must be of an appropriate size to carry the electrical load safely. The size of the cord is determined by its gauge, which indicates the diameter of the conductors. Cords that are too small can overheat and pose a fire hazard. Section 400.13 covers overcurrent protection. Flexible cords must be protected by overcurrent devices, such as circuit breakers or fuses, to prevent damage from excessive current. The overcurrent protection device should be sized appropriately for the cord's ampacity. Section 400.14 addresses equipment grounding. Flexible cords used with grounded equipment must have a grounding conductor to provide a path for fault current. This helps to prevent electrical shock hazards in the event of a fault. Section 400.17 covers portable cables over 20 mm in diameter. Portable cables larger than 20 mm require specific installation methods and support to ensure their safe use. These cables are typically used for heavy-duty applications and must be handled with care. Section 210.63 of the National Electrical Code requires a receptacle outlet to be installed within 25 feet of heating, air conditioning, and refrigeration equipment on roof ducts and in attics or crawl spaces. This receptacle is intended to provide a convenient power source for servicing and maintaining the equipment. The purpose of this requirement is to reduce the need for long extension cords, which can pose safety hazards and be inconvenient to use. The receptacle must be readily accessible and located in a place where it is unlikely to be damaged. The proposal to require ground fault circuit interrupter protection for indoor receptacles that also serve the purpose of servicing outdoor equipment is a safety measure. Ground fault circuit interrupters are designed to detect small electrical leaks and quickly shut off the power to prevent electrical shock. By requiring ground fault circuit interrupter protection for these receptacles, the risk of electrical shock is reduced when using extension cords to power equipment outdoors. The change clarifies that the National Electrical Code requirements end at the fixed premises wiring, regardless of what temporary conditions may arise in the use of that system. This means that the code primarily focuses on the safety of the permanent electrical installation and does not extend to the temporary wiring and equipment that may be connected to it. However, it is still important to follow safety guidelines when using extension cords and portable equipment to prevent hazards. The use of extension cords in construction is a common practice, but it also presents certain risks. Extension cords can be easily damaged, overloaded, or improperly used, leading to electrical shock, fire, or equipment damage. It is important to select the right type of extension cord for the application, ensure that it is in good condition, and use it in accordance with the manufacturer's instructions. In many areas, temporary services are erected on construction sites to provide power for tools and equipment. These temporary services typically include a meter, disconnect switch, and receptacles for connecting extension cords. The use of extension cords from temporary services is generally permitted, but it is important to ensure that the installation complies with the National Electrical Code requirements for temporary wiring. This includes using the appropriate type of cords, providing overcurrent protection, and grounding the equipment properly. It's important to note that the National Electrical Code is a set of guidelines and standards for electrical installations. Local jurisdictions may have additional requirements or modifications to the code. It is always recommended to consult with a qualified electrician or electrical inspector to ensure that your electrical installations comply with all applicable codes and regulations. In summary, the proposal to amend Section 400.12 of the National Electrical Code aims to clarify the rules regarding the use of extension cords, particularly in temporary situations. By exempting listed extension cords from certain restrictions, the proposal seeks to address common practices and reduce the potential for misinterpretations of the code. The proposal also emphasizes the importance of ground fault circuit interrupter protection for receptacles that may be used to power equipment outdoors, enhancing safety and reducing the risk of electrical shock. Furthermore, a clarification that the National Electrical Code requirements end at the fixed premises wiring helps to define the scope of the code and avoid confusion about its application to temporary wiring and equipment. Always prioritize electrical safety and consult with qualified professionals to ensure compliance with the National Electrical Code and local regulations.